Hello. We are going to see how to calculate the flow in a pipe with a slope and a drop. The calculation of flow in a pipe with a difference in level is a case often encountered, but which poses a small difficulty in principle. What generates the flow is the hydrostatic pressure, that is, the head height produced by the difference in level. What slows down the fluid are the pressure drops in the pipe and the kinetic energy that has been used to speed up the fluid. It is the dynamic pressure that will be produced by the system. Here, we have a pipe 5 meters long, with a diameter of 80 millimeters, with a drop of 2 meters. Click on the pipe to see the difference in altitude. Exit altitude, -2 meters. We are going to see how to calculate the flow in this pipe with the MechFlux Pro 3D software. Here, we have already done the whole network. We are going to start from an empty example to clearly show how to use this software. Our project data shows an 80 millimeters pipe. So we're creating an 80 millimeters pipe. We click on the duct editor, we enter the diameter, 80 millimeters. And the roughness, 1 millimeter. And we record this conduit. Here we have created the conduit that we will use in this project. I select it in the library, at the conduit level. And I drag it into my interface, to create a new network starting with this conduit. Another datum of our project is the length of the pipe, which is 5 meters. We are going to enter the length here, and we enter the drop, in altitude Z, of -2 meters. Apply the coordinates. And we validate, so here we have a pipe of length 5 meters, approximately. Altitude at the entrance, 0. And an altitude at the exit, -2 meters. So how do you know the flow in this pipe? We simply use the function, implement a gravity water intake. And we get our result. The software has therefore calculated the pressure drops created by the pipe, and the flow which balances the static pressure of the drop. We will display in color the pressures in the system. So here we have atmospheric pressure at the inlet when passing through the tank outlet. We therefore have a pressure drop, and we have a depression here, which evolves to atmospheric pressure at the outlet. We show a walk test. So we have our flow which is through our conduct. So here it is, it's not complicated to create a vertical drop, to insert a gravity flow, and to calculate the flow rate. Here we see the results in detail. We see the pipe pressure drop, and the network flow here is 55.94 cubic meters per hour. We stop the test. We are going to simulate the addition of a rising part. Here we go up 1 meter. So, we inserted a small conduit, and we restart the test. With the function, install a gravity water intake. So the flow is of course lower, because we have less total elevation. We can observe the pressures. So here, the atmospheric pressure is light blue. It is the pressure that we see here, and the pressure that we see here at the outlet. We see that the maximum pressure is found here, with a static height which generates pressure at the bottom of the elbow. We are doing a test ride. We therefore see the evolution of our pressure, with a maximum value here, and an overall flow of 35.63 cubic meters per hour. Under these conditions, we have therefore seen how to calculate the flow of a network with a gravity water intake and a negative drop with Mechaflux Pro 3D software.